Then the next thing is about the distribution, Paul's distribution. The distribution is nature or shape of the spread of data over range of values. We will see this soon, right? The collection of data to be cutted or into certain values, and we'll see the spread of it, right? We'll see that soon. And then the outliers. Right, the outliers is the values that lie far away from far from the vast majority of the other sample values. Right, so maybe like average data is in the middle, then an outlier could be extremely large or could be extremely small. Right, it is very far away from the majority of the data. Well, we will have way to define the outliers in the later, maybe in chapter 3, right? We'll see how. But that's what we're doing with outliers that are extremely far away from the majority. Well, the last one is time, right? And the change of those characteristics is change based on the time, right? So at this time, maybe for instance, the people's average height was this amount, 100 maybe. Or maybe 170 centimeters, but by time changing, maybe 10 years later, it will be 172 centimeters high, right, for people's height. So by the time changing, right, all the characteristics maybe also change. Over time, those things could be changed. Right? That's what the time is doing in our course still, right? In statistics, basically, not our course only. Right? That is the characteristics we'll touch in our course here. Right? The time maybe not, but other things we'll see. Outliers, variation center, we'll see next chapter, but the distribution of data we'll see in this chapter too. the section 2.2 is a frequency distribution. Well, it is a visual representation of data set that is partitioned among several classes, or in other words called categories, by listing the classes we have an original data set, and we separated or partitioned cut them into partitions, or partitioned them into several classes, and listing the classes values, and along with the number of data values in each of the class. So by this meaning maybe not that clear, but another definition for class. Well, each row is a category, basically. Right? The class is simply the row, which is also understood as a category. We'll see an example then, maybe clearly to see what is the frequency distribution does. Right, for those children lived near a lead smelter, the blood levels lower than 40 milligram per 100 milliliter is called low lead group. The concentration of lead in blood is lower than that amount. It's called low lead group. And their IQ scores are distributed as below. And the frequency is also listed along with the IQ score. as the group of IQ scores, right? That's 50 to 69, 70 to 89, 90 to 109, 100 to 129, and IQ score of 130 to 149. The frequencies the left is the categories, right? So there are the amount of their IQ scores. And the frequencies shows that, well, there are 2 kids have IQ between 50 to 69. There are 33 children have IQ score between 70 to 89. That's 35 kids have IQ score between 90 to 109. 7 of them had IQ score 110 to 129, and one kid has IQ score between 130 and 149. So that is called the frequency distribution, which has category being separated. All the kids has IQ score between 50 and 149, and there are how many? There are in total, let's see, right, 78 children. Then 2 of them have this first category, 33 has second category, and so on. Right? That is called the frequency distribution. So each of them is called class, and each of the number representing as frequency is called frequency, basically. Right? So other things. Right, which the smallest number of each class is called lower class limit. Or we can write as LCL for lower class limits. And those upper value or largest number called upper class limits. Right? Or being written as upper class limits, UCL. Right, so other things, I have to erase this. Which what we have seen was the table already. We can draw the table down. And another thing we have is frequency. A number of data values contained in a specific class is called frequency. Then class boundaries separate a number used to separate the classes but without gaps. What we had defined before was class limits. Right, for instance, we have 50 to 69. Well, we have the we have the classes, right, for individual number that's 50 to 69, 70 to 89, 90 to 99. We have in the middle have a gap 1. What we're trying to do is we make the graph and make each classes being connected together. That's the separation of each class between the classes will have no gap. Right, so how we do that is we take the average in the middle two number to get 69.5 here to be 89.5, and to make sure that it agrees with the original that we get 49.5 and so on. Right, for the classes that besides or instead of the limits of 50 to 69, we'll get the boundaries of first class become 49.5 to 69.5. The second class becomes 69.5 to 89.5. The third class will become 89.5 to 109.5, and so on. Right, so we make the separated classes with gap into no gaps. Right, so that boundaries are called class boundaries. Then of course we will have, like the class limits, we'll have the class boundaries. And our course here will only touch the gap between two classes will be 1. So that rule is always correct, that the upper class boundary and lower class boundary will be found in this way. Lower class boundary will be lower class limit minus a half. Upper class boundary will be upper class limit plus 0.5. And that is when it's true in the case that the gap is 1. Right? When the gap is not 1, then of course find the middle, right, to see what's the number add or what number should we subtract. Right, to be that. Our values in the middle of each class of the classes will be a little more confusing. Of each class, that means each class will have a class midpoint. Right, so we take the average between lower class limit and upper class limit. That is what the midpoint is. Right, for class width, we make sure that the width of each class are equidistant. Therefore, is the difference between two consecutive lower class limits or two consecutive upper class limits. Right, the difference between two consecutive lower class limits or two consecutive upper class limits is called the class width. Like we had before, 50 to 69, 70 to 89, that between 50 and 70, the difference is 20. We can also say between 70 to 90, the difference is 20. 60 to 89, the difference is 20. Therefore, we get the class width to be 20 simply. Right? It should be fixed for every class. Right? So we have just one way to find out the class width. So that is what we need to know of everything. Based on them, we'll see the graph, right? Simply called histogram next time, but Still, we need to figure out how these can be found for frequency distribution first. Right, so we go to them next time.